So 8.55, predict the ordering from the shortest to the longest of the bond lengths in CO, and then CO2, and then CO3 minus 2. So to be able to do that, you've got to draw the Lewis dot structures for all three of these. And then once we do that, we can look for the bond lengths between C and O in each one of them. So for carbon monoxide, carbon would be 4 valence electrons, oxygen would be 6, so we'd have a total of 10 valence electrons. Remember, carbon is in group 14, so it has 4. Oxygen is in group 16, so it has 6. Bond the carbon to the oxygen. Once we did that, we'd used up 2 valence electrons. We'd have 8 left, so 2, 4, 6, 8 wouldn't complete the octet, so you're going to need a double bond. Turns out you need a triple bond. That uses up 6. We have 2 4 valence electrons left, 10 valence electrons here. So this is a triple bond, which is definitely going to be very short as compared to a double bond or a single bond. So when we're going to compare bond lengths, this is probably going to be our shortest already, but let's draw the other ones to make sure. So CO2, carbon is 4, oxygen is 6 times 2, that's 12 plus 4, or 16. Put the carbon in the middle, bond the oxygens around it. We've used up 4 electrons there, 16 minus 4, that would give us 12 valence electrons left. 2, 4, 6, 8, 10, 12 would work on the oxygens, but then carbon would be electron deficient. So let's try a double bond here and a double bond here. That uses up 4 more electrons, 12 minus 4, that gives us 8 valence electrons left. 2, 4, 6, 8 valence electrons left. Notice this, we've got a double bond right here, so this probably would be like a medium bond length compared to a single bond, which would be the longest bond length we could get. But let's see what it looks like in CO3 minus 2. So carbon, of course, is 4, oxygen is 6 times 3, and then you got to add 2 more because you got a negative 2 charge out here. So 18 plus 2 is 20, plus 4 is 24. Put the carbon in the middle, bond the oxygens around it, and we got 3 oxygens going around here. It gives us 2, 4, 6. 24 minus 6 gives us 18 valence electrons remaining. If we'd go 6, 6, and 6, that'd use it up, but then carbon would be electron deficient, so we're definitely going to need a double bond somewhere. Let's try getting rid of the one pair of electrons right there. It gives us 16 remaining. 2, 4, 6, 8, 10, 12, 14, 16. Put it in brackets, put a minus 2 out here, and look at that. We have a resonating double bond. It could shift over to here, it could shift over to here, and then at any second it could shift over here. And so technically, we don't have a double bond here and a single bond here. We rotate this double bond to 3 different places throughout the structure. And so instead of having a single bond, we actually have 1 1/3 bonds between each one of these oxygen and carbon places in the molecule right here. And so if you were going to order the bond lengths from shortest to longest, CO would be our shortest, and then the little bit longer would be the CO2 bond, because that would be a double bond, and then our longest bond length would be the bond and a third, which would be a CO3 2-, and you can prove that through each one of the Lewis electron dot structures.